Right, in this lesson we're going to do a little bit more work on matrices. I'm going to talk about operations of matrices. We're going to look at how we add two matrices and how we multiply a matrix by a scalar. And also in the next video we need to learn how to multiply a matrix by a vector and how to multiply two matrices. But I'll leave a separate video on that because it's quite complicated and it's better to look at it in a bit of detail. Okay, so first of all, how do I add two matrices? I've got two matrices here, and I want to add them. Now the most important thing to know is, if you add two matrices, they must be the same size. If they're not the same size, then we'll say it's undefined, so there's no solution. It can't be done. But because these two are the same size, we can add them. Okay? So what I do is, I look at this one here, I look at row 1, column 1, I've got a 2 there, and I've got a 6 there. I add these, and I put an 8 there, in the exact same position. I've got a 3 there, and a 1 there. I add them, I get 4. I put a 4 in that same position. I've got a 1 there, a 2 there. I add 1 and 2, which is 3. I put the 3 right here, in this position. I've got a 5 there, and a 4 there. That's 9. I put the 9 in this position here. Right, we can also add 3 by 3. I've got a -1 and a 7, that's 6. I've got a 3 and a 0, that's 3. I've got a 3 and a 2, that's 5. I've got an 8 and a 4, that's 12. I've got a 6 and a -1, that's 5. I've got a 1 and a 3, that's 4. I've got a -2 and a -2, that's -4. I've got a -4 and a +4, that's 0. I've got a 3 and a 1 there, that's also 4. Okay. So, to add two matrices, we'll add the numbers in the same position. So, and then the answer, it goes in the same position. Okay, so that's the 1, 1 position, and that's the 1, 1 position. So we'll add the two numbers in the 1, 1 position, and we'll put the result in the 1, 1 position for the answer. And that's why I used that strange definition in the first video, because it makes it easier to explain things, even though it just seems a bit silly to start off with. It does you a lot of good in the long run. Next I want to talk about how you multiply a matrix by a scalar. I'm not going to go through what a scalar is, you should have learned it at school. It's quite simple, and all you do is multiply each number here inside the matrix by this number here, which is called the scalar. 0 times 2 is 0, so we'll put a 0 there. 2 times 3 is 6, so we'll put a 6 there. 2 times 1 is 2, so we'll put a 2 there. And a 2 times 7 is 14, so we'll put a 14 there. Okay, and next, what I want to do another example here. I'm going to multiply these by -3. -3 times 6 is -18, so I'll put that there. -3 times -2 is 6, put that there. -3 times -4 is 12, put that there. And -3 times 8 is -24, so put that there. Okay, So that's how we do that. And now let's look at the precise definitions of them. So say I've got a matrix here, A, and I've got another matrix here, B, and then I've got the anti-result here, which is obviously A plus B. I've got A11 here, A12, A13, A21, A22, A23, A31, A32, A33. I've got put B in this one, B11, B12, B13, B21, B22, B23, B31, B32, B33. So in the result here, because these are the same positions, we'll add A11 and B11. And we'll do that for each one. So there's the definition of it for you. Right, the definition for multiplying by a scalar now. So we've got some scalar here, C. We've got some matrix here, A. And I've got A11, A12, A21, A22. And the result will be C times A11, C times A12, C times A21, and C times A22. Okay. Now, there's very good properties for these. Like with normal numbers, A plus B is always equal to B plus A. Okay. And also, we've got more properties than that, which we can easily come up with. So I've written down here. Yeah. So C is also a matrix, capital C. So I've got A is equal to, always equal to that. That's another property. And this is for adding two matrices. Okay, and then another property would be that A plus 0 is equal to A, and 0 plus A is also equal to A. And another property is A plus minus A is equal to 0, and minus A is the same as minus 1 times A. Okay, so those are some important properties of that. Now I want to talk about the properties of scalars. So I've got two scalars C and D. The property is that I've got a scalar C. And just read these, quite easy. And that's equal to C times A. There we go. Now also another property is that if I've got two matrices A and B, then that's equal to C times A plus C times B. And also, more importantly, if I have the scalar 1, so that's A, 1 times A is equal to A, If I've got 0 times a, then I get 0. And you can check all these results by putting in numbers, and you'll always see that these results are true, okay? And the same for the adding as well. And that's very, very complicated stuff if you're seeing it for the first time. So if you've got any questions, put them on the video and I'll reply and try and explain it the best I can.